Imagine a world where your devices never run out of power. No more charging cables, no more frantic searches for an outlet. What if I told you that a single battery could power your phone for your entire lifetime, your children's lifetime, and their children's lifetime for 28,000 years straight? It sounds like science fiction, right? Well, it might be closer to reality than you think. And the secret ingredient? Something we usually try to get rid of: nuclear waste. This isn't just a concept. It is a technology being developed right now by a startup aiming to turn a major environmental problem into a revolutionary energy solution. They call it the nuclear diamond battery, and it's a marvel of modern engineering. The concept is both simple and brilliant. Take radioactive material, something we currently spend billions of dollars to safely store, and use it to generate electricity continuously for millennia. The company behind this has figured out a way to take this waste, specifically a radioactive isotope called carbon-14, and encase it in a shell of pure man-made diamond. So how does it work? Let's break it down. At the heart of this battery is carbon-14. This is a naturally occurring radioactive isotope of carbon, but it's also produced in large quantities as a byproduct in nuclear reactors. Normally, this carbon-14 is considered waste and needs to be securely stored for a very, very long time because it has a half-life of 5,730 years. That means it takes over 5,000 years for just half of its radioactivity to decay. Instead of just burying it, these scientists are putting it to work. They take this carbon-14 and compress it into a tiny pellet. Then comes the magic part. This radioactive core is completely encapsulated within multiple layers of synthetic diamond. These aren't the diamonds you see in jewelry stores. They are industrial-grade, lab-grown diamonds, known for being one of the hardest materials on Earth. This diamond casing serves two incredibly important purposes. First, it acts as a semiconductor. As the carbon-14 inside decays, it emits beta particles, which are essentially high-energy electrons. When these electrons hit the diamond structure, they knock other electrons loose, creating a small but steady flow of electricity. Think of it like a tiny, self-contained solar panel, but instead of capturing photons from the sun, it captures electrons from a decaying isotope. The second, and perhaps most crucial role of the diamond is protection. It's a super strong, impenetrable barrier. The beta particles released by the carbon-14 are relatively weak and can be stopped by just a few millimeters of solid material. The diamond casing is more than thick enough to absorb all this radiation, meaning absolutely none of it escapes. The battery is completely sealed and safe to handle. It's a solid-state device with no moving parts, no liquids, and no emissions. It's basically a tiny, inert, power-generating rock. You could hold it in your hand, and you'd be safer from radiation than you are when you get a dental X-ray. Now, you might be thinking, if this thing is so powerful, why isn't it in my smartphone already? Well, there's a catch. The nuclear diamond battery is not a powerhouse in the traditional sense. It doesn't deliver a huge burst of energy. Instead, it produces a very small, continuous trickle of power. We're talking microwatts. That's not enough to run a power-hungry device like a laptop or an electric car. But what it lacks in power, it makes up for in endurance. Unbelievable endurance. It will keep producing that small amount of power, day and night, for thousands of years. This makes it perfect for applications where longevity is far more important than high output. Think about devices in hard-to-reach places. Deep-sea sensors monitoring ocean currents, remote weather stations in the Arctic, or structural monitors embedded deep inside bridges and skyscrapers. Replacing the batteries in these things is difficult, expensive, and sometimes impossible. A battery that lasts for centuries would be a game changer. But the ambitions go even further, reaching for the stars. NASA has shown significant interest in this technology for deep space missions. Probes traveling to the outer reaches of our solar system, far from the sun's light, can't rely on solar panels. Currently, they use radioisotope thermoelectric generators, or RTGs, which are bulky, less efficient, and use much more dangerous radioactive materials like plutonium. These diamond batteries, on the other hand, are smaller, safer, and could provide consistent power for missions that last decades or even centuries. A probe could travel to distant stars, continuously sending back data without ever needing to worry about its power source dying. Back on Earth, the potential applications are just as exciting. Consider medical implants. A pacemaker powered by a nuclear diamond battery could last for a patient's entire life, eliminating the need for risky and stressful replacement surgeries every 5 to 10 years. Imagine hearing aids, insulin pumps, or other implantable devices that you get once and never have to think about again. And what about consumer electronics? While it can't power your entire phone, it could be used as a supplementary power source. Imagine a smartwatch or fitness tracker with a tiny diamond battery that constantly tops up the main battery. You might only need to charge it once a year, or maybe never again. The device's internal battery would handle the high-power tasks, while the nuclear battery ensures it never fully dies, keeping the clock running and basic functions alive forever. It's a marriage of high power and extreme longevity. The technology is still in its early stages, but the progress is real. Prototypes have been built and tested, successfully demonstrating the concept. The company is working on scaling up production and refining the process to make it more efficient and cost-effective. One of the biggest hurdles is sourcing the carbon-14 waste, but as more nuclear facilities are decommissioned, the supply of this raw material will only grow. This turns a multi-billion-dollar disposal problem into a multi-billion-dollar energy opportunity. It's the ultimate form of recycling. So, the next time you plug in your phone, think about this. A future where charging is a thing of the past. A future powered by tiny, indestructible diamonds filled with recycled nuclear material. A battery that outlives not just you, but entire civilizations. The question is, would you be comfortable having a piece of nuclear technology in your home or even in your body, even if it's proven to be completely safe? It's a fascinating thought. What other futuristic technologies do you think will change our world? Let me know in the comments below. Thanks for watching, and don't forget to subscribe for more deep dives into the tech that will shape our future.